Pretty short lesson today. It's section 6.4. It's on arc length. The formula for arc length is right there. You can read it. So arc length, the length of an arc is equal to the integral from a to b of the square root of 1 plus f prime of x squared dx. So that will give you the length of f of x on the interval from a to b. All right, so example 1 here, it's a calculator problem. It asks us to find the length of f of x equals natural log of secant x on the interval from 0 to pi over 4. So we've got the integral from 0 to pi over 4 of the square root of 1 plus the derivative of f of x squared dx. So we need the derivative of this. Derivative of natural log of something is 1 over this times the derivative of this. Derivative of secant x is secant x tangent x. All those rules are on page 244, I think it is in your book. 244. Secant x's can cancel here. So we get the derivative to be tangent x. And this one says it's a calculator problem. So we are going to graph square root of 1 plus tangent x squared. Make sure it's clear that you're squaring the tangent x, not just the x. And we need to integrate that thing from 0 to pi over 4. Double check, make sure you're in radians mode. And integrate from 0 to pi over 4. And we get 0.881. Example 2, this one is no calculator. Asks us to find the length of 2/3 x to the 3/2 from 0 to 7. So again, the rule is the integral from a to b of the square root of 1 plus the derivative squared. So we need the derivative. Derivative of this, move the 3/2 out front, gives me 1, subtract x, or subtract 1 from x. So we get the integral from 0 to 7 of the square root of 1 plus x. U substitute, make du equal, or make u equal to 1 plus x. So my du is equal to dx. Change your bounds. Plug in 0 gives me 1. Plugging in 7 gives me 8. Integrate. Plug in 8. 8 to the 2/3, or 8 to the 3/2 rather. Minus 1 to the 3/2. You could probably leave it like that if it is multiple choice and you need to simplify it. So we've got square root of 8 cubed. So we have 2 root 2 cubed. So it's 2 cubed times root 2 cubed 8 times root 8. (16√2). And you could distribute the 2/3 if you want. And then one more. This one is another one of these problems where it gives us a region. So it's bounded by y equals, or f of x equals 1/4 x. Here's g of x equals negative 1/27 x cubed plus 2. And it's also bounded by the x-axis. So it's this shaded region here. Usually we're looking for the area, or if we revolve it about an axis, find the volume. This time it asks us for the perimeter, so it wants the distance around this figure. This one is a calculator problem. So this point here is 0, 0. We can confirm that 0, 0 is on this curve. And if I know what this point here is, I can get this distance. We can find that by graphing. So we have 1/4 x. We have negative 1/27 x cubed. So there's 1/4 x. Here comes 1/27 x cubed. Oh, plus 2. I missed the plus 2. Not there. And let's change our window a little bit. So there's the line, and here comes the curve. And it's pretty clearly further out than that. That looks better. So here's our figure right here. We're looking for this point right here. So we need to calculate that 0. And that's a 0 of my y2. So I'm going to turn y1 off and then calculate the 0 that I'm looking for. It's hard to tell right now, but I think it was between 2 and 3. Maybe between 3 and 4. Let's go 2 to 4. That should get it. There it is. So 3.7798. So this side here is 3.77976. Because this point is at 0 and this point is at that value, and it's just a straight horizontal line. To get this distance right here, this line, it's a straight line, so there's a couple ways you could do it. Either way, we are going to need this intersection point right here. So let's get both graphs on and then calculate that intersection point. So that intersection point, so f of x is equal to g of x. At the point 3.19015, 0.79754. And then this point here is 0, 0. So because it's a straight line, you could use the distance formula there, or set up a right triangle and say this distance here is 3.190 and this vertical distance is 0.798, and then use the Pythagorean theorem to get that. Or you could use the arc length formula. Any of those are good options. I am going to use the Pythagorean theorem here. So it's going to be the square root of 3.19015 squared plus 0.79754 squared. So this distance here is 3.28833. And then we've got one more side we need to find. It's this side over here. And this one, while it looks kind of like a straight line, it is not. It's part of a cubic. So we know what this point here is. That's this point. That's this x value. And this point here had an x value of this. So we want to start at this x value, end at this x value, and calculate the arc length. Find what that distance is. So we are going to integrate starting at 3.19015 and ending at 3.77976 of the square root of 1 plus the derivative squared. And the derivative is negative 3 over 27 x squared. I don't need these anymore. So we've got square root of 1 plus negative 1/9 x squared squared. And our bounds are here. 3.19015, 3.77976. And this side is 0.992899. And then to get the perimeter, we just add those up. Your final answer needs to be accurate to 3 decimal places, so it's wise to make sure you round to probably around 5 on all this stuff, and then round your final answer off instead of rounding to 3 here, using those to get answers, rounding those off, and then adding all those up. Your answer is probably not going to be accurate to 3 decimal places anymore. Looks like a little bit more than 8 is the perimeter. So that is arc length. Section 6.4.